Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, fractional crude distillation. Now, fractional distillation is the separation mixture into its component part or fraction. Chemical compounds are separated heating them to temperature at which one or more fraction of the mixture will vaporize. It uses distillation to fractionate. Generally, the component part have boiling point that differ by less than 25 degrees centigrade. For each under a pressure 1 atmosphere, the difference in boiling point greater than 25 degrees centigrade, simple distillation is typically used. As an example, consider distillation of a mixture water and ethanol. Ethanol boil 78.4 degrees centigrade while water boil at 100 degrees centigrade. So, by heating the mixture, the most volatile component, ethanol, will concentrate to greater degree in the vapor, leaving the liquid. Some of mixture from azeotrope, where the mixture boil at lower temperature than either component. In this mixture of 96% ethanol and 4% water boil at 78.2 degrees centigrade. The mixture is more volatile than pure ethanol. For this reason, ethanol cannot be completely purified by direct fractional distillation of ethanol water mixture. Now, the fractional distillation column is set up with the heat sources at the bottom of the still pot. As the distance from the still pot increases, the temperature gradient is formed in the column. It is coolest at the top and the hottest at the bottom. As the mixed vapor is condensed, the temperature gradient, some of the vapor condense and vaporize along with temperature gradient. Each time the vapor condense and vaporize, the composition of the more volatile component in the vapor increases. This distills the vapor along length of the column. Eventually, vapor is composed solely the more volatile component. As an azeotrope, the vapor condenses on the glass platform known as tray inside the column and run back down into liquid below, refluxing distillate. The efficiency in terms of amount of heating and time required to get fractionation can be improved by insulating the outside of the column in an insulator such as wool, aluminum foil, or preferably vacuum jacket. The hottest tray is at bottom and coolest at the top. The steady state condition, the vapor and liquid on each tray, they are equilibrium. The most volatile component of the mixture exit the gas at the top of the column. The vapor at the top of the column then passes into condenser. They cool it down until the liquefied. The separation is more pure with the addition of more tray to a practical limitation. Heat flow. Initially the condensed will be close to atmospheric condition and then much of the ethanol has been drawn off. The condensate becomes gradually richer in water. The process continues until the ethanol boils out of the mixture. The point can recognize the sharp rise in the temperature in thermometer. The above explanation reflects theoretical way the fractional work. Normal laboratory fractionation column will be simple glass tube, vacuum jacketed, sometimes internally silvered, filled with packing, often small glass, helix, 4 to 7 mm, means 0.16 to 0.28 in diameter. Such a column can be calibrated distillation of a non-mixture system to quantify the column in terms of number of theoretical trays. To improve fractionation, the apparatus is set up. The return condensate to column use the sum of salt, reflux splitter, reflux wire, gigamagnetic swinging bucket. A typical careful fractionation would employ reflux ratio around 4:1, 4 part return condense to 1 part condensate takeoff. Now, alternate setup may use multi-outlet distillation receiver flask connected 3 or 4 receiver flasks to a condenser. By turning cow or pig, the distilled can clean it to any chosen receiver because the receiver does not have removed and replaced during the distillation process. This type apparatus useful when distilling under an inert atmosphere air sensitive chemical for a reduced pressure. A Parkin triangle is an alternative apparatus often used. This situation because allow isolation of the receiver, rest of the system, but does not require removing and reattaching a single receiver for each fraction. Vacuum distillation system operate reduced pressure, thereby lowering boiling point. Material anti-bumping granule, however, become ineffective. Reduced pressure fractional distillation, the most common form separation technology used in petroleum refinery, petrochemical and chemical plant, natural gas processing and cryogenic air separation plant. In most of cases, the distillation is operated a continuously steady state. New feed is always being added to distillation column and products are always being removed unless the process disturbed due to the changes in feed, heat, ambient temperature or condensing. The amount of feed being added, amount of product being removed and normally equal. This is known as continuous steady state fractional distillation. Industrial distillation is typically performed large vertical cylindrical column known as distillation or fractional tower distillation column with diameter ranging about 0.65 to 6 meter means 2 to 20 feet and height ranging from about 6 to 60 meter means 20 to 197 feet or more. The distillation tower have a liquid outlet, the interval up to the column which allow the withdrawal of the different fraction product having different boiling point or boiling ranges by increasing temperature of the product inside the column. The different products are separated. The lightest product, those with lowest boiling point, exit from the top of the column and heaviest product, those with the highest boiling point, exit from the bottom of the column. For example, fractional distillation is used oil refinery to separate crude oil into useful substance, fraction having a different hydrocarbon, the different boiling point. The crude oil fraction with higher boiling point have more carbon atom, have higher molecular weight, are less branch chain alkane, for darken in color, they are more viscous, they are more difficult to ignite, to burn. Large scale industrial tower useful achieve more complete separation product, reflux reform, portion of the condensed overhead liquid product and distillation or fractional tower that return the upper part of the tower. Large scale industrial tower, inside the tower, the reflux liquid flowing downward to provide cooling needed to condense the vapor following upward, thereby increasing effectiveness of the distillation tower. The more reflux is provided given number of theoretical steps, the better the tower separation. Lower boiling material from higher boiling material alternate, the more reflux provided to given desired separation, for fewer theoretical plates are required. Fractional distillation also use air separation product, liquid oxygen, liquid nitrogen and highly concentrated argon distillation of chlorosilane and also enable the production of the high purity silicon for use semiconductor. In industrial uses, sometimes a packing material is used in the column instead of tray, especially when lower pressure drop across the column are required. When operate under vacuum, the packing material can either random dump packing 1 by 3 inches 25 to 76 mm wide, such as resting ring or structure sheet metal. The typical manufacturer are Koch Schuessler and other companies. Liquid tend to wet the surface of the packing and vapor passes across this wetted surface where mass transfer takes place. Unlikely the conventional tray, the distillation in which every tray represents a separate point of vapor-liquid equilibrium. The vapor-liquid equilibrium curve in a packed column continues. However, the modeling packed column is useful to compute a number of theoretical tests to denote the separation efficiency of the packed column with respect to more traditional tray. Different shape packing have different surface area, porosity. Both these factors affect packing performance, design and operation. The distillation column depend on feed and desired product. Even simple binary component feed, analytical method such as McCabe-Thiele method, the Fenske equation used for multi-component feed, simulation model, and both use design and operation. Moreover, efficiency of the vapor-liquid contact device, preferred plate or tray used in distillation column, they are typically lower than that theoretical 100% efficient equilibrium Hence the distillation column need more plate than the number of theoretical vapor liquid equilibrium stages. Reflux refers the portion of condensed overhead product that is returned to the tower, the reflux flowing downward provided cooling required, the condensing vapor flowing upward, the reflux ratio, which is ratio of the internal reflux to the overhead product, is conversely related theoretical number of stages required efficient separation. The distillation product, fractional distillation tower or column are designed to achieve the required separation efficiency. The design of fractional column is normally made in two steps, the process design followed by mechanical design. The purpose of the process design is calculate the number of required theoretical stages and steam flow including reflux ratio, heat reflux and other heat duty. The purpose of mechanical design on the other hand, they select the tower internal, column diameter and height. In most cases, mechanical design of fractionation tower is most straightforward. For the efficient selection, the tower internal, the accurate calculation of the column height and diameter, many factors must be taken into account. Some of the factors involved in design calculation include feed load size and property when type of distillation column is used. The two major types distillation column used are tray and packing column. The packing column are normally used smaller tower and load that are corrosion or temperature sensitive or for vacuum service where pressure drop is important. Tray column of the tower and they are used the larger column with high liquid load. They first appear on since 1820. Most of oil refinery operations tray column are mainly used for the separation, petroleum fraction, the different stages oil refining. The oil refining industry's design and operation of the fraction tower is still largely accomplished the empirical basis. The calculation involved the design petroleum fractionation column require useful practice, use of number and numeric chart, table and complex empirical equation. In the recent years, however, considerable amount of work has been done to develop efficient and reliable computer-aided design procedures for fractional distillation. Okay guys, this is up to fractional distillations. I hope you get sufficient knowledge after watching my video. My video is particularly made for those people they are interested to gain some knowledge. Okay, still then, goodbye. Do take good care of yourself. Next Sunday we cover some another topic of chemical engineering. Goodbye and do take care of yourself.